Welcome to Skytree's webinar, Using Machine Learning to Find New Customers. My name is Ben Sawyer, and I'm the moderator for today's webinar. Quick side note, we are recording today's event, and we'll be sending out a link over the next few days for everybody to be able to view this recording. So today, we're going to talk about machine learning, or rather how machine learning can find your best potential customers in your data. We'll see how machine learning is used to accurately predict customer behavior in a way that isn't possible using the standard scoring and reporting methods currently used by most organizations. You're going to see a demo of our new application called Find New Customers, which allows you to accurately segment customers, predict future purchase behavior, and make determinations about the best marketing channels to reach your customers. Paul Salazar, VP of Sales here at Skytree, will be the main presenter today, along with Dr. Alexander Gray, professor at Georgia Tech and CTO here at Skytree. The main presentation will be about 35 minutes, followed by a 10-minute Q&A session. So please submit your questions through the chat to event host as we go along, and I'll read them off for Paul and Alexander to answer at the end. And if you have any technical issues, also just submit those to host in chat, and we'll get those taken care of. And now I'd like to turn over control to Paul and Alex for the webinar.
Thanks, Ben. We're going to focus right now on challenges that are confronted by marketing organizations and marketing executives. And at the core, one of the top issues that a marketing executive will confront is pinpointing and finding the best possible prospects for their salespeople to go after and win new customers. And organizations sometimes buy lists of prospects. They can gather them through their web forms or from events that they participate at. They can have signups and so forth. And what you end up with is a very, very large list. And then the question, how do you identify from your big list of data, from all of your possible data sources, the highest probability prospects that will convert and become customers? And once you've identified who are your highest probability prospects, a logical second task you're going to want to do is determine what is the right campaign to send to those prospects to convert them into customers. Because what's appealing for one of your prospects may not be at all appealing for the next. And you want to know more about those prospects and utilize your knowledge about them to make good choices, to do really accurate targeting. So businesses, of course, have lots of big data sources. They gather them. Everyone talks about that nowadays, how there's this relentless stream of new information that every organization has. Could be demographic data, fundamentals about your customers or your prospects, where they tend to live, what they tend to do for a living, and so forth. You might have a lot of behavioral data. People are collecting literally gigabytes and terabytes of clickstream data and other types of behavioral data that provide insight into prospective customers and what's their likelihood. Are they interested or are they not? Another category would be things like preferences. Sometimes people self-report on a website because they regularly shop at that site, because they have a loyalty program at a site. And they self-report a lot of information. They identify their preferences. And finally, based upon their activity, you may know more about them because they have previous purchase history and other types of activities that indicate, obviously, who are the higher likelihood candidates to convert to customers. But you need to put all of this data to work. And that's a pretty big challenge for most organizations nowadays because if you had only a small amount of data, you could probably just go by insight. You can look at your data literally with your own eyes or have an analyst do that from your own experience and make choices about who you want to target. But the world's not so simple, so a lot of organizations have stepped into using rules and rules-based engines that will guide and perhaps help to sift through some of that data. Or you may be using some simple analytics. You might be using SQL queries. You might be setting up and doing some basic types of segmentation. But what we want to talk about on today's webinar is advanced analytics, and more specifically what Skytree creates, which is machine learning. That broadly defined, it's that science of looking through large quantities of data, structured and unstructured, and finding patterns and using those patterns intelligently to make really accurate predictions about your data. So today's topic, of course, is marketing, and we're going to be primarily focused on how you can look at data to make smart marketing choices. But this is broadly applicable to a lot of different markets, and we'll touch on that momentarily. So the agenda for today is to give you a very brief introduction to our company, Skytree. We'll give you a basic overview of what machine learning is and what it does. Then we'll talk more specifically about machine learning with regards to segmentation and classification and how you would utilize Skytree Server for that. And finally, we'll walk you through a simple demo that illustrates how to put machine learning to work. As a company, Skytree has been around for several years. We've been exclusively focused on building out machine learning software, and very specifically for enterprise deployment. To us, that means that it's the kind of product that not only provides great results that are very accurate and very precise, but also does so at scale for large data sets and in enterprise types of environments. That's what we characterize as our advantage, because we are the only enterprise scale commercial machine learning system available in the market today. We're based in San Jose, California, with an office in Atlanta, Georgia, and we've been venture funded earlier this year and last year as well. So I'd like to turn the microphone now over to Alex Gray. He's going to provide a little snapshot into our company, into our team. Alex?
Hi, everybody. Can you hear me?
We can.
All right. So, yeah, I'll just say a bit about why we came to be. So this problem of making an enterprise-grade machine learning system turns out to be pretty difficult, in many ways more difficult than doing simple analytics to scale. It involves math, the math of machine learning and statistics. It involves computer systems research, expertise in data visualization and interpretation, and as well as high-performance computing to really do it properly to the extent that is known in the research world. We come from that world, and you can see here we have taken the very best people in all of these different areas that are constituents of this technical problem. These people you see here on our board, these are all National Academies members. That's sort of, think of that as the Nobel Prize of America. So these are the absolute best people in these areas. And in general, we remain a bridge between research knowledge and to product.
Great. Thanks, Alex. Let's talk about machine learning now and do a little quick backgrounder on that for everyone who's listening. Machine learning is really nothing totally new. It's really all around us right now, and you can't go through the world of technology and the world of business without bumping into it here and there. This is a technology that's emerged out of years and years of previous research and development in fields that are very diverse, founded in statistics, and leading up to the present where organizations such as Netflix have perfected the ability, for example, to make recommendations. Or things like Siri on the iPhone, or, for example, the placement of ads when you do a search on Google, are all on the back end utilizing machine learning methods to do very, very accurate computations and place information or provide answers to people at the right moment in the right way. It's very targeted and very, very selective. So machine learning is pervasive, but it's also been in the realm of some very specialty organizations and really not in the commercial realm for lots and lots of organizations. So if we look back a little in the historical context of where machine learning has come from, Alex, why don't you take us through this and give us a little background on machine learning?
Yeah, so machine learning, many of you may have just heard about it really in the last few years. Discussion has started in industry, and now every company is hiring like mad for data scientists and so on to do machine learning. But it's really been around for decades, arguably centuries. It's really just an extension of multivariate statistics, and has kind of appeared under many names which today are all really the same thing. So those include statistics, data mining, pattern recognition, in industry, sometimes advanced analytics or predictive analytics. And throughout the decades, there have been roots in artificial intelligence, and later throughout the 80s, neural networks, sort of synonymous with machine learning. But today, all the principles kind of discovered by these different areas have been fairly unified, and that has helped under the appearance of many high-profile, successful applications, as Paul just described a few of them, but it's also how your postal mail is delivered. It's just everywhere in certain specialized organizations, and now everyone wants to do it. But there is no commercial solution that is sophisticated, and so that's sort of the void that we're filling.
And when we talk about machine learning, one of the most important points we like to always make is it's really a technology oriented toward prediction and looking into the future. Alex, you want to highlight some of that on this slide here?
Yeah, just another point of confusion that's common today is that many things are conflated under the term analytics, but really we sort of divide analytics into two types. One is we call basic analytics. It's also very useful, but it's things like counts, averages, histograms. Generally, these are the kinds of things that can be done well by SQL queries or MapReduce jobs in Hadoop. But then a very different beast that's much more difficult, very different kinds of computations. These are the kinds of things where you want to automatically find patterns. You don't want to hand specify rules. So this is the realm of machine learning, automatically finding patterns and using them to make predictions. And that's sort of where everything is going, as our prediction, and that's about literally predicting. So in that sense, both senses, it's future looking as opposed to looking back at data and just trying to see what happened.
Another critical point is that machine learning has a very, very critical added benefit in that it learns over time. So you set up and train a model initially, but then as your system is operating and you're gathering more data points and you're reviewing more input stimuli, the system actually trains and becomes yet more accurate. And that's a very, very critical piece of what makes machine learning so advantageous, is that ability to automate learning and have that built in as a continuous process. And when you take this kind of technology, it's probably not surprising to anyone on this call that it's very, very pervasive. It can be used in many ways, for example, not just for sales and marketing, as we're focusing on this call, but also in real estate, in fraud detection and fraud prevention, in health and life sciences, very, very useful in the media space, in arbitrage, if you will, from purchase of ad space to the sale of that same ad space. And you can see in these use cases, again, this is what we bump into at Skytree with our own customers, is a very broad and very diverse set of use cases. The common threads among all these use cases, number one, is generally fairly big data that people are trying to learn from and utilize. Number two, the need for performance. You can't wait for something which is maybe designed for a lab setting. You need a production scale, enterprise caliber product to move quickly. And the third thing is precision. These are types of applications where a small delta in precision can make a great big difference in the absolute business outcome that we're trying to model or predict. So let's focus in once again on the specific topic for today, which is marketing, and in particular segmentation and classification using the Skytree server. When we work with our customers, when organizations want to implement machine learning, there's a three-step process. Let's take you through those three steps as to how you start to put this kind of technology to work. First of all, you have many data sources, and you want to pick data sources that are the most appropriate, that are going to give you the most information. Or in some cases, you can pick all your data sources and let the machine learning engine optimize and decide for you what kind of information is giving you the most input and the most guidance into your predictive output. Secondly, then you do what's called training or learning. And that's a period where you work with, typically it's your data scientist or an analyst, who's going to look at your data, who's going to look at your sources, look and utilize the available methods, the machine learning methods that are incorporated in the Skytree product, and then decide what business question are they trying to answer. So for today's topic, we're talking about, for example, to determine the probability of a prospect from a list of potential buyers, what's the likelihood of a given individual prospect to want to buy a product or service that you may be offering? And another thing is, once you've determined who is in your probable prospect class, what price are they going to pay, or what product or service will they want to buy, potentially from a range of offerings? We're going to address these very two questions in our demo momentarily. And then once you've tuned and tweaked and optimized your model, you put it to work. You put it into production, step 3. And you get an output. And what you want are actionable results. Once again, we'll see this in the demo momentarily. But an example for a marketing executive would be to make a choice. You have many, many different ways in which you can target your prospects, but you want to be sure that if you're going to use an expensive approach, an expensive marketing campaign, it's going to your highest value prospects. Or if you're going to use a low-cost, more mass appeal type campaign, it goes to perhaps a different class of prospects. So this is an illustrative example of how you might put this to work for a marketing organization. All of this, of course, gets put to work on the Skytree server. So I'd like to invite Alex back into the conversation to talk for a few moments about what we have in our product.
So Skytree server is the machine learning engine, sort of under the hood of the application we're talking about today. It's a general purpose, scalable machine learning server, the first one like that, that's really built from the ground up for massive data. And that is powered by fast algorithms as well as a unique architecture. And compared to other things, up to 10,000 times speed-ups. Can work on commodity machines, Linux, x86 machines, works on the cloud if you wanted to, virtual machines. But so this is your enterprise-grade machine learning system, and the only one of this level of sophistication that you would want to rely on as an enterprise.
And then, Alex, you want to walk us through some of the core mechanisms, what's happening under the hood here?
So I won't say too much about all the other things that you can do with machine learning, but if anything sparks your curiosity, we can talk later about it. But the kinds of things you can do, and you'll sort of see this later, predict categories or classes like buy or don't buy, predict a number, like how much you're going to buy, perhaps, break things into groups like high-paying customers and low-paying customers, maybe, or people from different buying behaviors in other senses. Density estimation would be how likely or unlikely are different things, sort of like a histogram, except in many variables at the same time. Dimension reduction is showing you in fewer variables what's contained in many variables so that you can understand it. And sometimes you want to find similar things, similar to the thing that you're interested in at the moment. So those are just some essential types of machine learning that can be done with Skytree Server. And machine learning is extremely horizontal, so everything essentially boils down to one of these tasks, or maybe a few others in more obscure cases.
Thanks, Alex. Okay, so what we're going to do next is we're going to move more into now the demo itself, and to set up what we're going to see on the Find New Customers demo. Let me take you again through these same 3 steps that we always go through every time we step into an analytics question and we want to get some answers out of Skytree Server. What do we do? So step 1, we're going to set up our data. And that's a very, very critical phase because you may have a variety of different sources The challenge and the task here is to determine what are the most relevant sources you want to be looking at, and you want to then do an import. So we typically would import from Excel or a CSV or over ODBC, and Skytree server basically then imports all of that information. The second step is a critical one. This is where your data scientist goes to work and doing exploratory phase of trying out different models by utilizing the various methods that are provided in the Skytree server, by incorporating the customer's own know-how, their experience, their familiarity with their own domain, and Skytree's expertise with the various machine learning methods and the various advanced algorithms. You create models. And typically this phase might go on for days or even weeks, where you are optimizing and really looking for that business output that's going to be most important. And at this stage, I just want to point out that with Skytree Server, we're not a black box. We don't sort of create your model for you. We don't have that as a secret IP or something else. Some organizations approach it that way, but what we do is we provide you the framework, a platform, a collection of methods, and we enable the data scientists to take those methods and put them to work and use them in different creative ways. So as an organization, our job is not to really do anything more than just enable and facilitate what the data scientist does already, which is to make great models that are going to have business value for the organization. So as an illustrative example of the next step, you take those models, and that production model you'll see on the lower left-hand side of the page. You take your production data sources on the upper left-hand side, and now you run them on Skytree Server in production. What I'm going to show you on our demo system is an example of an automobile provider, dealership network, that's making choices of how to segment prospects. First, deciding which are the most likely to become buyers of our cars. And then once we know who are in the buyer list, to determine amongst those buyers what category of vehicle would they want to buy. And actually in the background, under the hood, we're going to have two different methods that are running, because the model is sophisticated and it's going to be a very precise, very accurate model, enabling you then to create an output. And in this case, the output would be a series of personalized marketing campaigns. Very, very accurate, very focused campaigns. For example, you may want to run a print campaign which costs a certain amount of money for a particular segment of your target list. And then you would want to run maybe a more expensive, more posh type of event, invitation to a sporting event or something like that if you're trying to sell a very expensive luxury car, and that may be reserved for only a particular class of members that are in your buyer list. And then you may have a very, very wonderful gift you want to give away as an enticement as part of your marketing campaign. But if you're going to be spending a little or a lot of money on a marketing campaign, you certainly want to believe and know that what you're doing is done with a high degree of accuracy and precision, that you're utilizing your data in the best possible way to accurately target who you're going to be reaching. So let's go ahead and switch over right now to the demo itself. Here is our demo system. As you can see, it's for the Acme dealership network. And this is a demo of how you can now target new customers using the customer matchmaker system. That's what you're looking at here. And as you can see on the left-hand side, this should start to look familiar to everyone on this call now, because we're doing the exact same steps. First, we set up our data. Then we do some modeling and verify the quality and the accuracy of that model. And then we put that model into production, and we start to find buyers, and we match different models to the buyers. So as you saw earlier, you would have to get started, we import, in this case, a very, very large number of what we call learning data points. Let's take a peek right here. As you can see, we have demographic information and past purchase behavior on 32,529 entries into the system. And as an example, you can see that we have, if you scroll into the list here, an executive managerial male who's 40 years old with a bachelor's degree and is age 42. He's the buyer. Okay, so we can start to identify some past behavior from these previous buyers, and we're going to use this information to learn. This is what our system is going to use as a foundation for building up a model. So we go down here and we're going to press a button. Let's hang on until the screen catches up here. There it is. And we're going to go ahead and say, let's learn from this data. And as we do so now, in the background, you can see there's been some computation going on, and we have some initial results right here. So this is where your data scientist would want to step in. So I'd like to invite Alex back into the discussion here. And just briefly tell us what we're looking at, Alex.
Yeah, so we won't drill down into the details of these things, but you can just see that there are a number of different ways to measure the prediction performance of the model. So one way, this thing on the left here is one way among several that we have available to show you the trade-off between making false positives and the false negatives. So errors in both directions, calling a buyer a non-buyer or calling a non-buyer a buyer. And, of course, you don't just want to say buyer or not buyer. You want a probability that each person is a buyer. And you can use that to rank order your potential customers. So this middle thing here is showing a measure of how off your probability estimates are. And then you have this thing here, the confusion matrix, is showing you how many times you called a non-buyer a buyer and a buyer a non-buyer, so-called confusion matrix. So the important thing is that Skytree gives your data scientist is going to be tuning the model based on these different measures of performance, statistical performance. And Skytree actually completely automates that so that once you choose a metric of choice, Skytree will automatically tune the model to have the best performance in that sense.
And then the good news is, if you're the marketing executive, you know that your data scientist is happy. He's working with a fabulously exact product. He's built a great model. But the exciting step for the marketing person is to push the big button that says find prospects. So let's go ahead and do that right now. And what we just did is we fed the system a 1,000 long list of prospective buyers. And as you can see right now, if you look at the results, what we're getting here is a percentage likelihood that the various members of our group are actually going to want to make a purchase. In this case, purchasing a high-end vehicle from this dealership network. So now we've done that math. We can export this list into Excel if that's what the primary information is we're looking for. Or what you could say is let's pick a threshold upon which we declare that someone above a certain percentage is definitely a buyer and someone below a certain percentage is not a buyer. And we're now going to do some matching. We're going to use the matchmaker engine to match up models to buyers. So we click another button right here. We've done a computation in the background. Once again, the data scientist will be happy to see some pretty interesting statistics that give him a very, very clear picture. But what the marketing organization is really after is the following. Now we can say we've gone through that list of 1,000 and we found 11 entries that have an extremely high likelihood that they're going to buy the BMW Series 1. And you can see now there's Series 3 buyers and so on down the list. And you can scroll into these lists and you can see the various members of it. And of course, the way we've run this data, we've disguised, of course, names for privacy reasons. But you would have an index or you would have a name or an email address or a postal address. And now you're able to go out with a very, very fine grain and say precisely who are the folks out of this 1,000 strong list that are my 5 buyers, my 7 buyers, my SUV buyers, and so on through the list. So this hopefully provides a pretty strong and pretty clear illustration of how you would use machine learning to first and foremost predict the probability of a person being a buyer or not a buyer, and then to classify that person into one of these segments so that you can send the most appropriate marketing campaign into that group of individuals. That's what we think is really exciting about machine learning, because we're providing something here that is very, very deep, looking at a lot of data trends and finding truly the needles in the haystack, the things that you wouldn't necessarily have predicted based upon a simple analytics approach or a rules-based approach, but rather using the true breadth and depth of your entire data set to accurately pinpoint new buyers. So that's the core of our presentation today. What I'd like to do now is we're going to pause for a moment. Ben has been collecting up questions from viewers and participants in this webinar. And Ben, if you want to select a few questions and read them out to us, Alex or I can tackle those.
Sure. So it looks like we got quite a few questions. So please submit your questions into the chat window and send them to host, and I'll go ahead and read those off. And if we aren't able to get to your question today, we will certainly reach out to you via email and answer your questions that way.
And just to add, the way you get to the chat window, if you haven't seen it, is you hover your mouse pointer at the top, near the top, and then you'll see a button for chat.
So the first question we have here is the system a black box, or can you choose different machine learning methods?
Yeah, so that's one of the bigger contrasts between our solution, our approach, and others, is that we don't hide the machine learning bit from your data scientist, presuming that this is going to make money for your organization and potentially be a large driver for money. Probably not something you want to buy hidden inside a black box with no control over it, is our position. And so your data scientist probably wants to get in there and try to improve it and reason about what the machine learning is doing. And so our thing is not a black box. It allows you different tools, whatever is best, and gives you the best trade-offs in terms of various things like speed, accuracy, and interpretability.
Great, thanks, Alex. And next question, is the Find New Customers application going to be available for sale, and how much will it cost? Get that to Paul.
Great, yeah. Well, this application certainly is for sale. This type of application represents what we would characterize as our app offerings. This is a layer that's integrated on top of the core Skytree server. And the demo that we've been looking at, this is specifically optimized for a particular type of prediction. In this case, is designed for inputting collections of data for learning, collections of prospects, and doing a specific set of models. So depending upon what your particular business need might be, there would be a tweaking or tuning of this app, because you might want to use this application to, for example, not just find new prospects. It might be used in a research sense to find something new in a study. It could be used in a pricing sense to find an optimal price. There's a variety of ways to apply roughly the same approach, but that's something we could work out on a one-on-one basis with anyone who's interested. So, of course, if you are, you should be contacting us.
All right, and next question, how do you connect different data sources, for instance, from Teradata or from Oracle, etc.? Alex, you want to pick that one up?
So anything that's a table in any standard form is all we need as in the input to Skytree, as well as the output, whether a table or a column of a table, let's say the predictions and probabilities. So as long as it's a table, so ODBC we mentioned, CSV files, so any of those are fine. Hadoop.
We are generally speaking data source agnostic. We are not a data repository in and of itself, so we are not a data warehouse. We're not a Hadoop cluster. What we are is a standalone server into which you import, again, as Alex points out, tables of data, and you get out tables of results. So it's a pretty straightforward connection, and we try to keep it as simple as possible to enable the product to be incorporated into really numerous types of environments.
And then another question about the demo is, can we get a little bit more clarity, Alex, on those graphs that we looked at? What exactly are those?
Yeah, so that's I was sort of saying a little about them. Those are basically ways to characterize and then ultimately control the degree of that, for example, how often you make mistakes in one direction or the other, calling buyers non-buyers or calling non-buyers buyers, and also looking at how well, so just one little dive in what capture deviation is, for example. That's after the fact, after your model has done some predictions on some test data, you can then see, well, if those probabilities are well calibrated. It will actually turn out, for those of you who have ever done this kind of thing, machine learning doesn't always give great probabilities for off the shelf, and unless you actually really think about how to make that happen. So our software is very well calibrated as far as probability estimates. And the capture deviation, for example, as a way of measuring that, looks at if your probability estimate said that, let's say, in the top 10 customers, their total probability of buying was a certain amount, and then you actually count how many of those actually did buy. That's the capture rate, so to speak. How many out of the top 10 or 1,000, let's say, actually bought, versus what your software predicted it would, the capture percentage would be. So, and there are other metrics we're not showing here that allow you to really dive deeply into how well your model is performing in different senses.
Great, thanks, Alex. And another question here. So where does the data go exactly, and how secure is it, especially in the context of this demo that we just saw for that application?
Well, in this particular scenario here, and what is most common with Skytree's customers is to have a deployment of the Skytree server on site. So for many organizations, there's a high degree of privacy, and they don't want to take any risks with their data. So they keep everything on site. And so what's happening, as an example in our demo system here, is we are actually uploading these tables of data, the spreadsheet style data, into the system. It does its number crunching, and it emits additional tables out, as you can see on the screen here, which then you can use and segment and visualize any way you would like. But in terms of data security and data privacy, of course, everything is kept within an environment. If you can run Skytree server in the cloud, that's certainly not a problem at all. And there you simply have your own management of how you move data securely to and from a cloud-based solution. But once within the context of Skytree server, it's all a closed environment inside of the system.
Great, thanks, Paul. And another question here. So how is this different from Google prediction? And Alex, I'm going to send that one over to you.
So yeah, Google had, in past tense, a service called Google Predict, which is now been end-of-lifed. But the idea of that was you would send data to their servers, and they would, in a black box fashion, make predictions and send them back to you. So it's opposite to our philosophy. We don't think people really want that, and that potentially is validated by the fact that it's end of life. So, we think people want to, if the machine learning is important, which is the presumption here, then you kind of probably want to see what it's doing. You want to be able to change parameters, try different options. And the other aspect of Google Predict is that it was a cloud-based thing. You can do that perfectly fine with our system as well. So we have a cloud option. Many customers, don't necessarily want that. It kind of depends. But if your data is sensitive, you may or may not want that on a public cloud. But it may be a private cloud. So we do have that kind of option.
Thanks, Alex. Thanks, Alex. Yeah, and so we'll do one more question, and it's about the architecture. So is it software or hardware, and how does it work?
So it's definitely software. Just think of it as the same way you would think of buying a database or something. It's packaged software You install it on your machines. If you really have a big data problem, you install it on multiple machines and use our distributed version. Those machines are just commodity Linux x86 machines. So we're not also the hardware, although we can help you figure out what is some good hardware to buy if you need that.
Great, thanks, Alex. And that wraps up the webinar for today. If you have any additional questions, or if we weren't able to get to your question in as much depth as you wanted, please do reach out to us at info@skytreecorp.com. You should be able to see that email address on your screen. And I'd also like to invite you to sign up for our upcoming webinar about selecting the right machine learning method. And this is definitely geared toward more data scientists and technical people. And you can go ahead and go to the resources section on our website to webinars, and you'll be able to sign up for that. And thanks again, everyone, for attending, and have a great day.